Hello everyone, I am Monika Bhushan and today we are starting lecture number 11 of partial differential equation. Okay, so in last class, that means lecture number 10, we had seen Lagrange's form. The solution of Lagrange's form we got using grouping method. Fine. So the grouping method is done. So today's class we are going to see method of multipliers. So since we have covered grouping method and we have covered the complete concept of Lagrange's PDE and the reason of using Lagrange's auxiliary equation and all. So today we will not focus on those things, right? We are going to start with method of multiplier. Okay. Fine. So here are two questions which we are going to see today. So if you have not seen last class, then I will suggest you to first see that lecture and then only you come to this method of multiplier. Otherwise, many concepts today which we are going to skip since we have already elaborated in last class. So it might be difficult to understand. So what we have discussed, that suppose this question has come in your paper. So how you will understand that this is your Lagrange's form of PDE, because it is in the form of Pp plus Qq equals R. Correct? No. So P and Q we can easily mark out, and we have noticed that what is our capital P, what is our capital Q, and what is our capital R. Fine. So since we have got that this form is Lagrange's PDE, so we can move on the solution by the method which we have already covered, the grouping method. Always first we will try to start with grouping method because that is easy also, and that is taking less time. And if we will understand that okay, it's not going to be solved by grouping method, then we will try the method of multiplier. Fine. So now we are going to start this question. We have seen in last class that the solution needs 3 steps, correct? So step number 1 is here. Step number 1 is what? We are going to check that what is my capital P, what is my capital Q, and what is my capital R. So step number 1 is done. Fine. Now this is the step number 2. Remember? So step number 2 is actually very important step, because this step only going to give us the idea that what will be our answer, right? So here step number 2 starts with writing down the auxiliary equation of Lagrange's form, right? So this form is actually called as Lagrange's auxiliary equation or Lagrange's subsidiary equation. So the significance of Lagrange's auxiliary equation is elaborated in details in last class. So you can see from there, and then we will just start by assuming that okay, this step we have understood thoroughly, and then we will be solving this by, first we will be trying by method of grouping, and then we will understand that okay, method of grouping will not work here, so we will move to other method that is called as method of multiplier. So what we are done with, we are writing down dx by p. Capital P is x y minus z, capital Q is y z minus x, and then capital R is z x minus y. Fine. No? So these 3 things we have written down here. Fine. So now what we are going to do, always we will start with method of grouping only, because method of grouping will take always less time and it is easier also. So and it will take, if you have good practice, then it will, by scanning on the fractions only, you can understand that okay, method of grouping will work or not work. Suppose if I am interested in grouping between fraction number 1 and fraction number 2, so what will happen? I can see that here grouping will not work. Why grouping will not work? Because this is with respect to x, the derivative with respect to x, and in the second fraction the derivative is with respect to y. So the denominator term should not contain z. Fine, no, but I can see the z is present, and if z is present, so we can cancel out that z, but this is also not possible, so this grouping will not work. Otherwise you won't be able to integrate it. Fine, no, why? Because my step number 3 is what? Integration, and my goal of step number 2 is always, whichever method you are going to follow, the goal of step number 2 is what? To make the step number 3 easier. Okay, What is your step number 3? Integration. So to make integration term easier, we are actually focusing completely on my step number 2, simplification. So what about my grouping between fraction 2 and fraction 3? So here we can see that dy is present in second fraction, dz is present in the third fraction. So x term should not be present, not only in the denominator. Suppose you have something written down here also. So the x term, it should not be present, and if it is present, so we can cancel out. If it is in the denominator, so both places we can cancel out. Similarly, grouping between 1 and 3 will not work, because this is dx and dz. Still I can see y, and then y also cannot be cancelled out. So this grouping will not work in this type of auxiliary equation. So my approach is to go for method of multiplier. Okay, so now we are going to discuss that what is this method of multiplier and what is why we are calling it actually multiplier. So the reason is, here we will be actually taking 3 multipliers. Any name, suppose the name is given here LMN, 3 multipliers we are going to choose. Those LMN can be constant, fine. Those LMN can be any functions of x, y, z, and this LMN can be same, can be different also, correct? No, the whatever, suppose you are taking constant, the constant can be same also, or different also, that doesn't matter. Fine. So what I'm going to say here, so these 3 multipliers, why we are taking, because we can see that 3 fractions are there, and multiplier is, what is the property of that multiplier? Suppose I'm writing down here 1 by 2. 1 by 2 is equal to, if I'm writing down 1 by 2, then if I'm multiplying and dividing both with 2 only, 2, 3, 4, anything, but both are if same, so this is same, correct? No, so that means this fraction is actually equal. Similarly, I can write down 3 into 1 by 3 into 2. That means even if I'm writing down 3 by 6, so 1 by 2 is equal to my 3 by 6. Fine, no? And if you will see that what multiplier you have used here, so you have used multiplier 3. So same thing, if I'll say that I'm going to multiply L in the numerator also and in the denominator also, so this is same. I'm not violating any rule of this equal sign. Similarly, if I'm multiplying M in the numerator and denominator in my second fraction, and if I'm writing down N in the numerator and denominator, so still it won't be having any problem, correct? No? Fine. So now the use of this multiplier is what? I'm going to write down one more fractional term. Fine. So with the help of this method of multiplier, actually I'm going to add one more equal fractional term. Okay, and that fractional term will be in some different form. The form will be what? The form is, here in the numerator I'm going to write down this, whatever I have chosen, this first multiplier L into dx. Okay, this is what your L into dx, this term I'm writing down, plus m into dy. Okay, m into dy plus n into dz. So n into dz, and divided by what I'm going to write down, L into capital P. Capital P is x, y minus z. So I'm writing down L into capital P plus this is what? M. So this is your M into this y, z minus x is my capital Q. So capital Q plus this N I'm writing down, and then this z, x minus y is my capital R. Okay, so I'm writing down in this fashion. So I have to choose the multipliers in such a way that writing down in this fashion will be actually equal to other fractions. And if it is equal to other fractions, so all 4 fractions I can equate with, that is my k. That is okay? Fine. So one thing is important here to understand, that why I'm writing down multiplier in this fashion. Right, what is the reason to write down multiplier in this fashion? So the reason is, actually if we will little bit elaborate on the reason of writing down the multiplier in this fashion is what? The reason is, again the same thing, the step number 3, that means to make the integration in my third step simplified. And how I am going to make the integration simplified by writing down in this fashion? Because in last class we had seen that my goal of solving of this Lagrange's PDE, whether I am going to use method of grouping, method of multiplier, or method or combination of grouping, multiplier and all, the final answer is what I want to get, phi u comma v equals 0. In this fashion I want to write down the answer. Phi is any arbitrary function. What are u v? We have seen that u and v are nothing but some relations between x, y, z. Correct? Now v is also what? Some relation between x, y, z, and that equals c1 and c2. C1 and C2 are what? The arbitrary constants. So why I am equating u, v with C1 and C2 respectively? Because that solution of Lagrange's auxiliary equation is nothing but the integral surface. Okay, so call them integral surface. We need to actually integrate after my step number 2, because once I will be done with the integration, I will be getting two arbitrary constant, two integral constant. Actually, these two integral constants are nothing but characteristic curve constant. Okay, so since I will be getting two integral constants C1 and C2, that C1 and C2 we will be equating with u and v, and that u and v will be my answer. Fine. So since if you have seen last class, then you will understand that what here we are talking about. Okay, since u and v are two independent solutions lying on xyz space, so we want to write down in one step only, in one fractional part only, dx also, dy also, and dz also. Okay, because all together with some relation, actually they will form my u and v. After integration we will be getting them as u and v. Okay, so now we are going to focus on only these two things. Okay, so these two things only I am going to focus now. And then what does it mean if I am writing down L dx plus m dy plus n dz divided by Lp plus mq plus nr equals k? That means same thing I can write down what? I am writing down the numerator as it is, L dx plus m dy plus n dz equals what? Equals k into the denominator I have taken into the right hand side. That means L capital P plus M capital Q plus N capital R. That is okay, right? I have not done anything extra here. Now suppose this combination LP plus MQ plus NR, I'll write down in such a manner so that this complete additional part will give you 0. Okay, I'm writing down here. So that means if LP plus MQ plus NR is 0, that means K into 0 will give you what? 0 only. That means L dx plus M dy plus n dz will become 0. Correct? Why? Because we have said that this Lp plus Mq plus Nr is 0. So this numerator is 0. Fine. And this is very helpful term for us. And the reason why this is helpful, because if I reach here, I'll say that my step number 2 is over. And now I'm moving to step number 3. That means since I have got in one term only the relation between dx also, dy also, dz also in my one term only, so what I can say that if I will integrate that complete left hand side and the right hand side, so what will happen? So if I will integrate both places, so my left hand side will give me something with respect to x also, y also, z also, and the right hand side will give me what? Integration of 0 is what? Integration of 0 is nothing but some arbitrary constant. Is that okay? Why I'll say that integration of 0 is some arbitrary constant? Because what is integration? Integration is what? You can say that opposite of my differentiation. Is that okay? If you will differentiate any arbitrary constant or anything, right? If I write down here, if you are going to differentiate, suppose with respect to x, d by dx of 1, d by dx of 1 will give you 0. Why? Because this is any constant. Even d by dx of 1000 will give you 0. D by dx of any constant you are not sure that which constant, if I'm talking about some arbitrary constant, d by dx of any arbitrary constant will give you 0. So fine. So in the same manner, I will say that integration of 0, just opposite if I'll go, integration of 0 will give me any arbitrary constant. I'm not saying that it will give me 1 only or 2 only or 100 only or 1000 only. Anything, any arbitrary constant, it is for sure going to give me if I'm going to integrate 0. Is that okay? Fine. So if we understood this term, then that means we are done with our second step. What we have said that now we are going to choose the multiplier. So what multiplier I have to choose, that will come with practice. Okay. So this is only something what we have to work on in my step number 2. So this part is only with some trick. We have to understand that what multiplier should I use so that it will be 0. The reason we have discussed, but now we are going to understand that what will be my LMN. So for that, we'll just see that what is my PQR. So PQR, if I'm going to add, right, because I have to add PQR with some multiplier. So if I will add them, how it will be, it will give me 0. So actually in this case only, in this case actually, now only it is going to give me 0, right? No, because this will be what? This will be my xy minus xz plus yz minus yx plus zx minus zy. So minus xz and then plus xz plus yz minus yz minus xy plus xy, here only it is going to give me 0. How? By looking at these fractions only we can say, because you can see that here this is the cyclic form, y minus z, z minus x minus y. Fine. So this will come with practice actually. So that means I'm not going to multiply anything. That means the multipliers are 1 only, correct? No. So if I'll say that my L, M, N all are equal, that is also okay. They might be equal also. They all are if 1. So that means it is going to give me LP plus MQ plus NR equals 0. That means this term has become, if I'll say that this term is, if I'm taking this term into my right hand side, so completely this part will become 0. That means L dx plus M dy plus N dx is also 0. Correct? No. That means what we have said here. So this completely, this has given me 0. So this is my right hand side. Why? Because we had said that L dx plus M dy plus N dz equals k into LP plus MQ plus NR, and then this is 0. That means my L dx plus M dy plus N dz is 0. Fine. So what is my LMN? They are 1 only. That means dx plus dy plus dz equals 0. So the step number 3 says what? You just integrate left hand side and right hand side also. The reason of integration is what? I'm interested in that integral surface constant C1 and C2. So if I'm going to integrate both sides, so that means I can write, if I just separate out them, it is integration of these 3 things. Fine, no? Equals some constant, the name of constant I am writing down C1. Okay, so now this is your x plus y plus z is C1. Since you got this is your C1 and we have said that C1 only I am going to write as my u. So we got what is my u? U is x plus y plus z. Fine. So we got my, if the solution is phi u comma v equals 0. So instead of u, I will be writing down x plus y plus z. But now I am interested in what is my v. So the same process I am going to follow again. That means after that, what I am going to write down again, I am going to choose 3 different multipliers. Fine. So 3 different multipliers I am going to use the names, just we have written down L dash, M dash, N dash, such that same reason why we are saying that this L dash P, plus M dash Q plus N dash R should be 0, because after integration it is going to give me the other constant, the name we will be writing down as C2. Fine, no? So here only some trick we have to apply, that how now it will be 0. Right now 1 1 1 we had got. We can see that y minus z plus z minus x plus x minus y all together will give me 0. That is okay. So Here in my first set of multipliers, we had just written down 1, 1, 1. Now, what I can say, I just am interested in making these things 1 only. For that, I can write down into 1 by x. So, my L can be my 1 by x. If I remove this y, that means my M will be 1 by y. If I will remove this z, that means I want to write down 1 by z. So what will happen? So if these things will get cancelled, so I'll say that this plus this will give me 0. Okay, so for that I'm going to say that my L dash, M dash and N dash are nothing but 1 by x, 1 by y, 1 by z. Okay, so if I'll write down in this fashion, so what will happen? I will get 0. Now what about my left hand side? I mean the right hand side we got. That means what we are saying here, that L dx plus M dy plus N dz, they are now dash, equals k into what here, this is L dash p plus M dash q plus N dash r. Since this completely we have got 0, that means this term is nothing but 0. Okay, and L dash, M dash, N dash are what? 1 by x, 1 by y, 1 by z. So if I have got here this term, now this is my step number 3. Right now, step number 3 is what? Just integrate both sides. So I am integrating both sides. Fine. So now what I am writing down here? So if I see that, what does it mean? If I am writing down here 1 by x dx, integration of complete left hand side, plus 1 by y dy plus 1 by z dz equals 0, integration right side also I am writing down. So I am separating it out, 1 by x dx plus 1 by y dy plus 1 by z dz equals, just I am writing down some name, C2. And 1 by x dx, integration 1 by x dx is what? Log x. Fine, no? 1 by y dy, integration of 1 by y dy is what? Log y plus log z. And I have said that this is nothing but C2. Fine. Now, the same thing I'm going to say what we had discussed in my last class also, that instead of C2, here there won't be any problem if I will write down log C2. Why? Because what is C2? I don't know. I don't know the value of C2 right now. I just know the nature of this answer. I know the nature of the result of this integration. The result of integration of 0 is some arbitrary constant. So that some arbitrary constant can be C2, can be log C2, can be C2 square, can be C2, C3, C4, anything. The nature will be what? The nature is it should be constant, some arbitrary constant. So log of C2 will also be some constant only. Some value I will be getting, that will also be some constant. So I can write down here log C2. And the reason of writing down here log, not 1 by C2 or 2 into C2 or 3 into C2, because I want to make this equation simplified. To make the equation simplified, if I'm getting that all these places have log, so because of that reason I'm writing down here log. So because we know that log x plus log y plus log z will give me what? Log x into y into z. Fine, no? Log x into y into z will give me log x plus log y plus log z. And then log C2, that means I came to know that my C2 is xyz. Okay, because if I take anti-log both sides, I got that C2 is xyz. And C2 only I'm going to replace with the other independent solution, that is V. So I got V is xyz. Finally, I got here the solution of this Lagrange's PDE is phi. This was my u, this is my v, equals 0. Fine. Okay. So now we are going to see the second question. So the second question again, suppose it has come in your paper. Before everything, you will just need to know that whether it is eligible to form Lagrange's PDE. So yes, this is my capital P, P plus capital Q, Q equals R. And because we can see that first term contains P, second term contains Q, and the right hand side doesn't contain any PQ. So we got my step number 1 done. Step number 1 is what? I'm going to write down what is my PQR. Now, what is my step number 2? I'm going to write down Lagrange's auxiliary equation. So this is the system of equations where I'm going to write down 3 fractional terms. Fine. So this till here things are okay, correct? No, so till here whether you are going to use grouping method or method of multiplier, the steps will be same. So in your exam you can check with grouping method also, correct? No, this is dx and dy and zz you can cancel out. Similarly dy and this is dz, so and then x you can cancel out. But here in this class we are going to say that we are going to use method of multiplier only, okay, but you are allowed to use method of grouping also. But in this class we are going to check how method of multiplier will work in this question also, okay. So now what is my job? I am going to actually write down the fourth term, the fourth fractional term also, and that fractional term will be what? That will be my something lmn 3 multipliers which I am going to choose. So with the help of that 3 multipliers I am going to write down the fourth fractional term. That will be what? L into my, here it is what, a into dx, plus it will be my m into b dy, plus lmn c into dz, divided by what I am going to write down, L into this complete thing. This complete thing is what? This complete thing is my capital P, plus M into this complete is your capital Q. Fine, no? Plus N into this R, and that will be nothing but my K. Okay. So I think you understood that why we have written down in this fashion, because this a just taken in the numerator, okay. So this will be your b minus c yz only, fine, no. Similarly this b if I take in the numerator, so it will be only c minus a xz, and similarly c I have taken here, so it will be only this much, fine. So because of that reason only we have written in this fashion, okay. So what I am going to say that here only I have to understand that what combination I will make here within this LP plus MQ plus NR, so that it will become 0. But before writing down it 0, what fashion I have to write down here? The numerator, if I'm writing down the numerator as it is, this will be nothing but K into, right? This is nothing but your K. So K into this complete denominator thing which I have taken into the right hand side. Fine. So if I'm writing down in this fashion, so I'm saying that this complete term I'm going to make as 0. So K into 0 will be 0. That means this numerator, this complete thing will be my 0. And then I'm going to integrate. Then I'm going to come into the step number 3. Okay. So my goal is to write down LMN in such a way that so that this LP plus MQ plus NR will become 0. Okay. So if here only if you will see, suppose I am going to write down these three things together, if I am adding it, so what should I write down here? Some multipliers, so that it will be 0. Again you will see that here B minus C, C minus A minus B. So that will be actually if added together will give me 0. But we have something more in each terms. So the first term contains yz, second term contains xz, and then third term contains xy. Suppose I'm making if I'm multiplying z here, if I'm multiplying y here, if I'm multiplying z here, so xyz I will take common. Okay, so I will take xyz common, and then what I'll write down here, because I'm adding everything, because I have to add here everything, so it will be what? B minus C plus C minus A plus A minus B, and then A minus A, C minus C, B minus B, that means it will be 0 only, correct? No, so it will become 0. So that means I have taken my L as X, M as Y, and N as Z. Fine. So this choosing LMN will come with practice. Okay. So that means what we have said, that we have written down here, yeah, we have made these all things as similar. So for that I have taken this common, and this complete term will become 0. Okay, if it has become 0, that means your numerator term also has become 0. Fine, no? So here L was my X, M was Y, and then N was my Z. Fine. So for that, what I'm going to write down, my step number 3 is what? I'm going to integrate left hand side also and right hand side also. So A, B, C are constant, so taken out, it is nothing but x dx, then integration y dy plus integration z dz, and then integration of 0 I'm just writing down is nothing but C1. Okay, so integration of 0, I'm writing down c1. So integration of x dx is what? X square by 2. Integration of y dy is what? Y square by 2. Integration of z dz is what? Z square by 2. Since I'm seeing that in my left hand side, everywhere the denominator is 2. Fine, no? So because of that reason only, to make the complete equation in simplified form, instead of c1 what I have chosen, I am writing down c1 by 2. So there won't be any problem because I don't know what is c1. The nature of c1 is constant. If the constant is divided by 2, it will again give me constant only. So I can write down c1 by 2 also. So writing down c1 will make this equation easier. I just cancel out the denominator part from everywhere. So I got my c1. c1 is what? c1 is ax square plus by square plus cz square. So I got my c1. c1 is only I'm going to replace with u, the first independent solution of my integral surface of Lagrange's PDE. So this is your you have got. Fine, no? Now, since I have to get the solution in this fashion, I got my u. U is nothing but ax square plus by square plus cz square. I want to know what is my v. So to get to know v, I am going to write down 3 more multipliers I have to choose. The multipliers name will be L dash, M dash, N dash. Correct? No. Now, my job is actually the step number 2 is nothing but apply some trick so that this L dash P plus M dash Q plus N dash R will become 0. So for that reason, what I am going to write down here. So this is my P and then Q and then PQR, correct? No, so this first multiplier was done. Now what next I can write down here? Okay, now also I'm going to multiply with xyz with some more multiplying factor, because then only it will be easier to take these three things common. So if I will multiply in my first term with a, okay, and then if I'll multiply the second term with b, the third term with c, so again you can see that I will, after addition, I will get 0. That means what I'm saying, I'm writing down here AB minus AC plus BC minus BA plus CA minus CB, and taking XYZ common, because XYZ again I have added here X, Y and Z multiplied here. Okay, so what will be happening here? AB minus BA minus AC plus CA plus BC minus CB. So still you will get 0. Fine, no? So that means here your L dash is AX, your M dash is BY, okay, and your N dash is CZ. Fine. So that only we are writing down here. Fine. So that means we have got the numerator part here, because already a b c was multiplied there, so now it is nothing but a square b square c square. A square b square c square are constant, so taken outside, and the same thing, right? Integration of x, integration of y, integration of z, and then here we are writing down other constant, that is c2, and we got, right, because of these two we have taken them cancelled, so we got what is my v. So fine. So this is my u and this is my v, and we got the answer. In today's class, we have just seen method of multipliers applied in all questions. In next class, we are going to see how the combination of method of grouping and method of multiplier will work. Okay, so if you find this class useful, please like and subscribe my channel. Thank you.